All right, algebra students, in this video we're going to cover vertex form of quadratics, and I think you'll find this to be a little different, something that you may not have ever done before, but actually a little bit easier than a standard form. Okay, there's still a little bit of a process to do. The vertex form of a quadratic is f of x is equal to a and then x minus h squared. Okay, a lot of times people forget about that exponent out there, and then plus k. The AH and k all mean some things. First of all, your vertex can be made up of h comma k. Once again, inside the parentheses we always go opposite. So it says negative h inside your parentheses. Your vertex is actually at a positive h. Okay, your axis of symmetry is x is equal to that positive h because it's the x value of your vertex, and then the a will determine the direction if it points up or down, and the width, how wide the thing may be. Okay, now easy enough. The vertex shows the vertex of a quadratic equation respect to its parent function, and the parent function is f of x is equal to x squared. Okay, so that's the parent function. You can pull it up on your graphing calculator or on Desmos calculator to see exactly what it looks like. Okay, now the first 6 questions ask for us to determine what this thing would look like compared to the parent function. Number 1, it's not moved right or left at all because you don't have any parentheses. This one is just up 9. Number 2 would be just down 2. And you can graph these to see them if you'd like to. Okay, number 3, first of all, we got that negative out in front. So we got that negative out in front. And then so that's going to make it reflect across the x-axis. Same as when we had the negatives out in front of our absolute value equations, okay? And then that plus 5 is going to make it move opposite of that, so left 5. Okay? Number 4, we're not reflected or anything. This time we're moving right 4. And the minus 1 out in the back would be down 1. Right 4, down 1. Number 5, first of all, we've got up 2. Okay, that's probably the easiest one. But then you're thinking, what does that 1/3 mean? Well, because it is less than 1, it is a vertical compression. Some people don't like compression. They would rather me refer to it as a shrink, and that's fine too. But then that would be by 1/3. Vertical compression by 1/3. Number 6, finally, we've got a reflection across the x-axis. And then on this one we have a vertical, and it would be a stretch. And then we say by 2 units, okay, or by a factor of 2, I mean. So by 2. And then it also moves left 4. Okay. Number 7 says Mason graphed the parent function of a quadratic. Then he reflected the parabola. I'm going to highlight some key words here. First of all, we've got he reflected the parabola over the x-axis and then translated it 7 units up and 3 units to the right. And says what is the equation of our new parabola. So it would be f of x is equal to, first of all, he reflects it. Okay, it doesn't say anywhere that it has been stretched or compressed or shrunk or anything like that. But there's a negative because it's reflected. Okay, first of all, right or left. Okay, it says 3 units to the right. You got to go backwards on that, so minus 3. Don't forget about putting your exponent on the outside there, x minus 3 quantity squared. And then it says 7 units up, so plus 7. And there you have it. Now, let's get to the meat and potatoes of this stuff and let us graph it. It says give the vertex and the axis of symmetry and then graph them. Okay? First of all, our vertex, I'll just put a V. Our vertex, you can find it really easy. And that is by looking at this number right here. Always go opposite. So instead of -2, we're going to put a positive 2. And then outside of your parentheses, you got a positive 3. So that's going to be your y value. And your axis of symmetry, it is x equals 2. So we can plot all that stuff. X equals 2, straight up and down, through the 2. Looks like that. 2, 3, 1, 2, 3 would go right up there. So basically what we have done is we have taken all of those things that we did with standard form and we almost cut our work in half. Our 2 goes in the middle. Guess what? We're going to go 3, 4, and 5, just like what we did the other day. 1, 0, and a negative 1. One thing that we can't tell on this one is we can't tell the y-intercept. It's just because it's in a different format or whatever. But we know that our vertex was at 2, 3. So let's plug in some of these other values. Okay, let's plug in 1. 1 minus 2 is negative 1. Negative 1 squared is a positive 1. 1 plus 3 is 4. So 1, 4, 1, 2, 3, 4, and 3, 4 would be up like that. If I plugged in a 0, you would get, let's see, 0 minus 2 is negative 2. If you square it, you get a positive 2. And 2 plus 3 is 7. So at 0, it would be up 7 and put a dot. And then on the other side, we could reflect that other one and to be at 4, 7. Last but not least, let's try 5. 5 minus 2 is 3. 3 squared is 9. 9 plus 3 is 12. And that's not going to fit on our graph, so I'm just going to leave it out. And so you look, and you see that our graph, our U-shaped thing, looks like this. Okay? So being able to identify what the vertex is and the axis of symmetry really helps us out. Our vertex on number 9, we don't have any parentheses. So it's going to be at 0, and then it's down 4 at negative 4. And so our axis of symmetry would be at x equals 0. Okay? I'm going to fix my 4 here a second. Negative 4. Okay, so 0 is going to be at negative 4. We know that for our output. Okay, let's draw our axis of symmetry. And let's draw our vertex down 4. Okay, I don't think I talked about this one on the last one, but on this one it is positive, so we know that it should point up. So we're going to plug in 1, 2, and 3, but we could also do negative 1, negative 2, and negative 3, and plug those in. At 1, 1 squared is 1, minus 4 is a negative 3. That means that this is going to be negative 3 also, over 1 down 3. Okay, if I plugged in a 2, 2 squared is 4. 4 minus 4 is 0. So over 2 is at the 0. If I plugged in a 3, 3 squared is 9. 9 minus 4 is 5. So over 3, up 1, 2, 3, 4, 5. Over 3, 1, 2, 3, 4, 5. And there's your U-shaped curve that we've got. And there you have it. Let's flip it over on the back. More of the same. Number 10, we know it's going to point down. Okay, so our vertex, first of all, on number 10 is going to be at a negative 5, opposite of that 5, and then a negative 1. We know that our axis of symmetry is at x equals negative 5. Okay, so we go left 5, and it's going to be a dotted line. Axis of symmetry is going to go through here. This one's going to point down because it's negative out in front. Negative 5, comma, negative 1 is our vertex. So there is our maximum. Okay? Now, let's plug in some other values. I'm going to go negative 4, negative 3, negative 2. You could go negative 6, negative 7, negative 8 if you'd like. The smaller numbers, the better, though. Okay, once again. So negative 4 minus 5, negative 4 plus 5 is 1. 1 squared is 1. But there is a negative on the outside there. Okay, so that becomes a negative 1. Negative 1 minus 1 is a negative 2. Okay, so we get a negative 2 in each of those. So we go over negative 4 and down 2. And you can already see where this thing's going to go. Negative 3 minus 5 is, plus 5 is 2. 2 squared is 4. There's a negative out there, so it's a negative 4. Minus 1 is a negative 5. Okay? And then if I plotted that, let's see, -3, and then 1, 2, 3, 4, 5 would put us there, and I believe there. Last but not least, -2 plus 5 is 3. 3 squared is 9, but we'll make that a -9. Minus 1 is a -10. So I think this one's going to fall off our graph. I don't think there's enough room. So if we plot it, if we drew this U-shaped thing, our parabola, it's going to look like that. Okay, number 11, our vertex on this one is at 4. I don't have anything on the outside, so it is at 0. Our axis of symmetry on this one is at x equals 4. So I go over to the 4. Let me do it in red. 2, 3, 4, and I put a dotted line there. That's our axis of symmetry. Our vertex is at 4, 0, so it would be there. So 4, 0 is going to be right in the middle. Then I'm going to do 3, 2, and 1. So when I plug in 3, 3 minus 4 is -1. Okay, when I square it, I get a +1. And then times 3 gives me 3. So over 3, 1, 2, 3, up 3 puts me there. And then on the other side would be there. If I did 2, 2 minus 4 is -2. -2 squared is a +4. 4 times 3 gives me 12. And I'm already going off my graph. So if I finished it off and I did this last piece, 1 minus 4, that's -3. Squared is 9. And then you get 27 for your output there. Your U is going to be very skinny, like this, because that 3 is bigger than 1. Okay? Let's try number 12. Number 12, we've got piecewise. So it gets more fun when you can do piecewise functions. First off, let's do this guy. We'll do it in red. That one is a straight line. It helps if you can figure out what the shapes should look like. And that top one is a straight line. That's a linear equation. So go down 6 and put a dot. Then go down 1 over 2. Down 1 over 2. And I'm going to also go up 1, left 2 a couple of times. I don't know the way this line's supposed to, or where I'm supposed to cut it off with just yet. So that's what my line should look like. Okay, now there is a -2 for my domain, so I need to go where it's less than where I'm trying to highlight right here. So my line's going to go up this way. Okay, I'm going to erase everything else. This is where would be less than -2. So let's draw that part of the line. Oops, that's better. So that's the line that I need to draw. All the other stuff I can erase. Okay, get rid of all this other stuff that I don't need. And clean it up just a little bit. All right, now to the bottom one. The bottom one is a parabola, okay, because it's a U-shaped thing. It has that parentheses and squared and all that sort of stuff. Well, the vertex on this one would be at a +1. It didn't say you have to, but I'll put it 1, -5. Okay, so over 1, and then down -5. That puts you kind of right in there. Okay, if you were to make yourself a little table, an X and Y table, that's what I would suggest to do on these, and then figure out what it is that you need to start plugging in with your stuff. Now, typically in the middle, we'd put the 1 and then the -5, and then we would go from there. And so I would always go towards 0. So 0, -1, and then -2. And actually, that -2, it just so happens that it gets included in with our domain that we're talking about over there. So if I plugged in a 0, 0 minus 1 is -1. If I square it, you get a +1. 1 minus 5 gives us a -4. So 0, -4. And then if we reflected it, it would be over there. If I plugged in a -1, -1 minus 1 is a -2. Squared, you get a +4. 4 minus 5 is a -1. So -1, -1. And then if we reflected it, it would be over there. And then last but not least, a -2 minus 1 is a -3. -3 squared is 9. 9 minus 5 is 4. So, try to change that, is 4. And so if I go -2, I'm going to go up 1, 2, 3, 4. Okay, now at this particular point, I could put a dot right there and then kind of go 1, 2, 3, 1, 2, 3. And that gets me my idea of my U-shaped thing. But if I were, you could have caught this ahead of schedule and said that it's not going to be included with that -2. So right there at that -2, I actually need a open circle. And then the rest of my graph is a U-shaped thing that goes up like this. Okay? By the way, the, ooh, you know what? I made a little bit of a mistake also. At this red one, that did not include the -2 either. So at that one, I almost messed that up. That would have been an open circle as well. So your domain, I don't think it asks for it on here, but your domain would be x does not equal -2. It's everything else, but not equal to -2. Your range would be everything that was greater than or equal to this very bottom point right here. It looks like that is 1, 2, 3, 4, 5 at -5. So -5 would be your greater than or equal to -5. Okay? Didn't ask to do that. Some folks are still struggling with domain and range, so I figured I'd do it anyway. Okay? Number 13. 13, we've got a quadratic on top. Okay? So if we were to look at that one first, we don't have the parentheses and all, and that's fine. Our vertex would be at a 0. That's because we don't have the parentheses, and then a +6. So 0, 6 would be up here. Okay, and then again, I think that it's helpful to draw your little table where you got your x's and your y's. 0, 6 is right smack dab in the middle. I'm going to go 1, 2, 3 this way. Okay, that way I can erase if I need more room. If I plugged in 1 to that top one, okay, 1 squared is 1, times a -2 is a -2, and then +6 is 4. So at 1, we go up 4. 1, 2, 3, 4. Put a dot there, and then if I reflected it, it'd be over there. Okay, now I'm going to pay close attention because it says x is less than or equal to 1. I'm going to continue to draw the left-hand side of this, but I'm not going to worry about the right-hand side because I know that I don't need to go anything past to the right of +1 because it says less than or equal to 1. If I plugged in a 2, 2 squared is 4. 4 times a -2 is a -8. Add 6 and you get a -2. So over at 2 we get -2, so it's down here. Okay? It would have been over here, but I'm not worried about that. Okay? If I plugged in a 3, 3 squared is 9 times -2 is a -18. Add 6, that's going to be off our graph. So all I'm really worried about is this U-shaped thing that stops right there. And there you go. Okay? I stop right there again because I stop and it is equal to that +1. So I stop right there. Now the bottom one, I'll do this one in blue. Okay? This one is a linear equation. So I go up 4, 1, 2, 3, 4, put a dot. Okay? I don't need that part of the line. I'm not going to make it too heavy. And then it's down 3, 1, 2, 3, over 1. Okay? 1, 2, 3, over 1. 1, 2, 3, over 1, and then 1, 2, 3, over 1. Okay? The only thing I need to be careful about on this one is that there should be an open circle where this line is at a +1 because it's not included in there. So, open circle right here. And then it's everything else that goes after that. Okay, so the bottom one in blue. The top one, I actually drew it in, put all the dots in red, but the top one would be in black. Domain on this one is all real numbers, okay, because where there is a hole, there's a dot filled in up above it. The range would be y is less than or equal to 6, +6. Okay, same thing goes. We got 2 more for inequalities. Same thing goes for those. We can graph them exactly the same way. We would go right 3 and put a dot. We know this one should point down. So this one is at 3, 0. That is your vertex. Okay? Your axis of symmetry is at x equals 3. So that helps you to draw your dotted line. Go for it. Okay? All right, now we need to plug in some other values. So 2, 1, and 0 would be the ones that I'm going to do. 4, 5, and 6 would be our reflected ones. Okay, this is an inequality. It's the same graphing methodology, except it's going to be a dotted line or solid line, and we're going to shade. Okay, so if I plugged in a 2, 2 minus 3 is -1. -1 squared is a +1. But there's a negative out in front, which makes it a -1. So over at 2, we go down 1, and then we reflect it. If I did 1, 1 minus 3 is a -2. -2 squared is 4, but it's a -4 because of the negative out in front. So over 1, down 4, and if we reflected it, it would be over like that. And then 0 minus 3 is -3, squared is a +9, but there should be a -9 out in front. And that one actually I think goes off your graph. This one, look at the symbol before you start drawing lines. It should be a dotted line because there is no line underneath. So we're going to draw our dotted line. And there you have it. Also, pay attention. This one is less than. So we want to pick a point, any point on the graph, and you want to shade down. And there you have it. There's your shaded region. Last, but certainly not least, number 15, our vertex would be at -1, -7. We can tell that because it is the opposite of the thing inside the parentheses, and then we go down 7. Okay? So -1, -7. If I plugged in some other values, I think that would be helpful to go 0, 1, and 2, but you could do -2, -3, -4. Okay, but if I plotted -1, -7, we're going to be all the way down here. Okay, axis of symmetry is at x equals -1. Okay, next thing to do, let's plug in 0. 0 plus 1 is 1. 1 squared is 1. 1 times 4 is 4. Minus 7 is a -3. So at 0, we go down 3 and we put a dot. And then we flip it over and put a dot. At 1, 1 plus 1 is 2. 2 squared is 4. 4 times 4 is 16. 16 minus 7 is 9. So again, we're just plugging in our x values and seeing what we get. And I think that's all that we can actually do. If I tried the 2, you get 3 squared, that's 9. 9 times 4, end up getting like 29. But honestly, like, you can stop when you realize you're going to be off the graph. It's fine with me. Okay, this one is a solid line. Solid line because there is a line underneath our symbol. So let's draw our U shape with a solid line. This time, it's greater than. And we pick any point we want to, and we shade up. And it just so happens it's in the middle of these two of our U-shaped parabola. And there you go. This will be your assignment. Again, it's very similar to the notes. Hopefully you guys watched all the video. If you have any questions, let me know.